All right, so today we're going to look at cos graphs. We've done sine, we're going to do cos today. And we are going to use the same x values as yesterday. We're still going to use 0 and pi halves. How are you confused already? We haven't done anything yet. We're going to use pi. We're going to use 3 pi halves. We're going to use 2 pi. So exactly the same as what we did yesterday. And we're going to use our unit circle to see what the other values should be. So if you look at your unit circle to see what cos of 0 is, for cos of 0 we get 1. Okay? For cos of pi halves we get 0. Laura, what do we get for cos of pi?
For cos of pi we get
-1, marvelous. What do we get for cos of 3 pi halves? 0. And then what do we get for cos of 2 pi? 1. Okay. So all those numbers just come from the unit circle. There's no mystery there. You guys notice how similar these are to the numbers we had yesterday? Yeah, so they're pretty much the same. What's different about them? They're just in like different spots, okay? So when we graph today for cosine, our cosine graph is going to look like this basically, but it's just going to be shifted a little bit. So the values are happening, they're just not happening at the same place that they did before. So it's going to look like this, it's just going to be shifted over. So we can start the graph just like we did yesterday. We can put our dark lines in the middle. We can still count 4 boxes to put our pi. So at this point, I have done everything exactly the same as what I did yesterday. Nothing is different. So my first point is 0, 1. So I've got 0 and then go up to 1 and I put a dot. My second point is pi halves 0. So pi halves is halfway between 0 and pi. My third point is pi -1. My fourth point is at 3 pi halves 0, so that's right in between pi and 2 pi. And then my last point is 2 pi 1, and don't connect them yet. So just leave your dots there to start with. Or kind of like a V, right? Yeah. So students will draw this incorrectly. Don't copy this because this is incorrect. Students will look at this and they'll be like, yep, that's a V.
Oh yeah, that's what I
But this is comparable to what we did yesterday, so here's what I want to show you. If we take a sine graph and I cover this up, what do you see? That V shape, right? But is it completely a V? Is it straight lines? No, it's curved. These are nice curved lines. Awkward. Awkward. Okay. Kind of as awkward as what Deja said when Mr. Guilford walked in. So, we can't say it now because I'm recording, it's not appropriate. Alright, so we make these curved lines. So we've got half of a bowl shape or half of a parabola shape right there. Then we've got this little curve shape down here. Right? Say that one more time. It does. So this has to curve like an upside down U. And this has to curve like a right side up U. And we're going to follow the pattern again, okay? So here was the pattern. We start up at 1 and we end up at 1. How is that different from sine? Yeah, sine starts at 0, ends at 0, right? So that's different. We start up at 1, we end up at 1. In the middle, we dip down to -1. So start up at 1, end up at 1, dip down to -1 in the middle. And then for us to connect between +1 and -1, we must cross 0. For us to connect between -1 and +1, we must cross 0. Okay, so the 0 happens in the other middles. Okay, so I'm going to start up at 1 and end up at 1. In the middle, I'm going to dip down to -1. To get from +1 to -1, we have to cross 0. To get from -1 to +1, we have to cross 0. And then I'm just going to make sure that these look like little U shapes. So if it's above the line, it's an upside down U. If it's underneath the line, it's a right side up U shape. The other thing I was noticing when I taught first period is that they were not putting arrows on either end. We have to make sure that we put arrows. Okay.
Besides the graph, anything else?
So we're going to label stuff on the graph just like we did yesterday. So what is this line right here called? Midline. Why is it called the midline? Because it's the middle line. Clever name, isn't it? What am I labeling right now? Amplitude. So what's the amplitude for this graph? 1. So that's the same as yesterday. What am I labeling right here? The period. So what's the period of this graph? 2 pi, right? So 2 pi. So the period of the graph is how far it takes to complete the pattern. So you start up, and then you dip down and come back up again, and that's where you end. You're back in your starting point. And so the period of the graph is 2 pi. The same as yesterday, right? We did that yesterday. How about the domain? Negative infinity to positive infinity. How about the range? -1 to 1. So, how comparable is this to what we did yesterday? Almost identical. Yeah, it's just been shifted over. Okay? In fact, if you look at this, if I drew my y-axis right here, that would be a sine graph. Do you guys see that? Everyone see that? So if I took my y-axis and just moved it over, that's a sine graph right there. So cosine graphs and sine graphs are the exact same. They're just shifted versions of each other. Okay? And they're the same because they use the same points. They haven't matched up quite exactly, but they use the same coordinates. Okay, we're going to go ahead and flip to the back page. We're going to practice only 2 of these today because I think we're going to be quicker to pick it up, maybe, than yesterday, hopefully. All right, what amplitude do you guys want to try? 7. Didn't we do that yesterday?
Yeah, let's do 4.
Is that just your favorite number? We're going to do 4.
We did 4 yesterday.
4 cos. What is a number that you guys want to have for B? 3.
Oh, we did do 7 yesterday.
Okay, so we're going to do y equals 4 cos of 3. So what is the amplitude of my graph? 4, okay. The formula to find the period of the graph is 2 pi over b. And what is the b value? 3. So our period is going to be 2 pi over 3. Okay. Should I be scared to draw a fraction?
Maybe.
No, why not?
Because you could just do the 4.
I can just count 4 boxes, put it there, call it good. Okay. So I'm going to count 1, 2, 3, 4 boxes, and I'm going to put 2 pi thirds. And I'm going to count 1, 2, 3, 4 boxes and put negative 2 pi thirds. And I'm doing that because I'm lazy and I know it's easy to graph. Okay. How about the y-axis?
4 at the top and negative 4
4 at the top, negative 4 at the bottom. Okay. So let's draw a sketch of the regular cos graph so we can remember it. So where do we start, where do we end? So we start at 1, we end at 1. What happens in the middle?
Go down.
You dip down to negative 1. What happens between these 2 points? We cross 0. What happens between these 2 points? We cross 0.
So if this were negative, would the little bone shape go under? Okay.
So we have an amplitude of positive 4. So where should I start and where should I end?
4.
Start at 4. End at 4. What do I do in the middle?
Go down.
I go down to negative 4. What do I do between these points?
Draw a
Go
bone.
through 0. What do I do through these 2 points?
Draw a bone.
Go through 0. And then I'm making sure that this is a curved graph. Okay. And I'm going to do the same shape on the other side. So I start up at 4. And I end up at 4. And in the middle I dip down to negative 4. And between the first 2 points I cross at 0. And between the second 2 points I cross at 0. And you will know that you drew this correctly if you can trace it with your finger and you go down, up, down, up, down, up, down, up, down, up, and nothing ever happens. It's just consistent. Consistent and the same. What's the domain for this graph? And what's the range for this graph? Marwa, make sure you type to the person that it's negative 4 to 4 so they know, okay? I wouldn't have known, but I just am guessing that you're not graphing like this. It's hard, right? All right, next one. What amplitude do we want?
7. 8.
Is that your favorite number?
5. 2.
Let's do 2. We're going to do a negative, though. We want to try a negative graph.
But no, because we did 7 with the other graph instead of 8.
8 pi.
We are going to do 1/8 pi
7.
x. 1/8 pi x. We're trying to make this look scary. Do you feel like it looks scary?
No, because we don't have a 7.
All right. What is the amplitude? 2. What's the negative mean if it's not part of the amplitude?
Rover.
Okay. To find the period, we do 2 pi divided by b. What is the b value for this problem? 1/8 pi. So what happens?
So the pies cancel out.
Pi's cancel.
And then you do 8, which is 2 times 8.
Yeah, so we have a number over a fraction, so we keep it, change it, flip it. And 16 is the period of the graph. It's a large number there. All right, so let's go ahead and draw our lines. How do you guys want to do your boxes for that 16?
8.
count 8 boxes and put 16?
Right. Count 4 boxes and
So
put 8.
1, 2, 3, 4, 8. 1, 2, 3, 4. We'll put 16. 1, 2, 3, 4. 1, 2, 3, 4. Would it have been wrong if you counted 4 boxes and put the number 16 right there?
No.
Would it have been wrong if you counted 12 boxes and put the number 16?
No.
How about if you counted 6 boxes and put the number 16?
Yeah.
You could count any number of boxes and put the number 16 you want. It's just easier. You can be lazier if it's easy to divide it by 4. It doesn't mean it's accurate or inaccurate. It means you're being lazy, and we're totally okay with that. Okay, so make your life easier by choosing something that can be divided by 4 easily. Okay, how about the amplitude of 2? How do you guys want to label this?
Top.
So 2 at the top, -2 at the bottom?
Yep.
Perfect. All right, so a normal coast graph does what?
Start at the top.
Yeah.
Oh.
So start at the top and end at the top. What does it do in the middle? Go down. What does it do between the first two? Cross 0, cross 0. So it is opposite. We're just drawing the normal one. I'm doing that to help you guys memorize it. Okay, so this one has an amplitude of 2, and it's reflected. It's negative. So instead of starting at 1 and ending at 1, it should start at -2 and end at -2. So make sure you end it at 16 since the period was 16. Yeah, if it's underneath the line, then the bowls are right side up. If it's above the line, the bowls are upside down. So starts at -2, ends at -2. What does it do in the middle? Goes up to +2. What does it do between these points? Cross 0. What does it do between these points? Cross 0. Okay. And then we draw these looking curved. And then we draw another one, right? We always have to have 2 periods of the graph. So we start at -2 and we end at -2. And in the middle we go up to +2. And in the middle of those we cross 0. And then in the middle of these we cross 0. So what's the domain for this graph? What's the range? -2 to 2. All right, number 1. Y equals negative cos x. Y equals negative cos x. Number 2. Y equals 2 cos 3x. Y equals 2 cos 3x. Y equals -1/3 cos of 1/5 x. Number 4. Y equals 5 cos of 2x. Other side. Number 5. Y equals -2 cos x. Number 6. Y equals 4 cos x over 2. Number 7. y equals negative cos pi over 3x. Number 8. Y equals 3 cos 11 pi x.